Alright, hell yeah. So we have physics for scientists and engineers, and we're going to do an easy problem. You know, someone was just like, hey, even the easy ones are hard. And so, man, this is like only a page and a half, but it's called estimates, and order of magnitude calculations. So what the goal is to get an answer within, If you say 10 and I say 100, hey, we're close enough. We didn't say 1 and we didn't say 1,000. So that would be within a couple orders of magnitude. But it's kind of cool if you use this process, you can get, within one order of magnitude. So it'd be like how many blades of grass are in your backyard. Maybe there's obviously probably more than 1,000. But is there less than 1,000,000? And is it 100,000? Could you say definitively it's 100,000 and not 1,000,000? Could you say definitively it's 100,000 and not 10,000? So those are the things, and I think one of the huge, or like I guess not caring is really important. I think that can be a tipping point to get really smart really fast, because then you can kind of see through. I don't know. You can, even take this. It says assume that at 7 minutes. I don't even like the number 7. It's not nice. So, and then to fill 30 gallons. I don't even like the number 30. So even this one, we can totally. So that's the goal, is to like maybe not even use the pen, and try to do this order of magnitude. Now this problem doesn't say find the order of magnitude, but let's just assume it takes 10 minutes, to fill 100 gallons. I don't know. That sounds about right. 10 minutes to fill 100 gallons. And even that is, so what I'm bringing up is like this idea of juggling. Where it's just like, even right now, my brain can't handle 10 minutes to fill 100 gallons. You know what I mean? What my brain could handle right now is 100 minutes to fill 100 gallons. Oh, and then just like that, instantly my brain's like, oh, if it takes 100 minutes to fill 100 gallons, I'm filling gallons at a gallon a minute. You know what I mean? And it's amazing. And so I guess I can't write anything. I really want to, because I want to do my little diagram of cars. Because we all just know how fast things go. If I have a town that's 60 miles away, I drive 60 miles an hour. Well, hell yeah. I'm going to be, well, I know a few things. I know I'm going to get there within an hour. And then each mile, hey, well, I mean, even that, we're not even using the same units, but we can definitely say that we're going to be going a mile a minute. Every minute we're going to be going a mile. All right, so this wants to calculate the rate. Oh, damn it. All right, hell yeah. So we're back, and it says calculate the rate, and even just that word rate, no one likes that word. So, but anyway, calculate the rate at which the tank is filled in gallons per second. Even just this, I don't even want to answer that. I want to calculate the rate at which the tank is filled in gallons per minute, which we just did. If it's 100 gallons, if it takes 100 minutes to fill 100 gallons, it's going to be 1 gallon per minute. Cool. Let's move on to the next question. We did that. And then check this out. Whatever we did to figure out what 100 minutes was to fill 100 gallons. If we did anything with those two numbers, we have the number 100 and the number 100. So, and then it is like Blue's Clues. What do you do to the number 100 and the number 100 to get, what we say? We said 1 gallon per minute. So we got the number 1. So how, Blue's Clues style. How do we get this number 100 minutes and 100 gallons, but then we can just instantly throw out the number 1? Well, and then that's the thing, is just like physics, and then most all of science, well, physics particularly, is usually just a lot of multiplying numbers and dividing numbers. More so than adding and subtracting. So. And it's because of this rate, because everything's like per second, or, it comes up a lot. But but then the confusing thing is like, well, what the hell are we multiplying or what are we dividing? And so that's where, getting rid of the actual problem and making it into something that you like, that's what I do all the time. And then we'll answer the question. 100 and 100, well, obviously we would just divide those two. Cool. And so for whatever reason, we take 100 divided by 100 and we get 1. Now, even right now, this is where one of the physics books was just like, hey, here's two options. What do you think it is? That is the worst. And this book was touted, you know what I mean? It's just like, but it was kind of an interesting book. And they even had multiple choices of A, B, C. There is no worse way to learn physics than say, hey, what do you think is going to happen, A or B? Well, because physics is kind of like, there's a lot of magic to it. You know what I mean? You're just going to be like, well, I think A. Well, no, you're wrong. It is B. And then you're just like, okay, I hate physics. So doing it that way of just like having, every time you have like a fork in the road where there's a 50-50 chance, just assume you're just going to totally mess it up. But anyway, but yeah, and then I like to do the units are the equation. So we'll just get right to it. So if it says gallons per second, you know what I mean? Like that just spells it out. That we're going to take the gallons, that 100, divided by the 100 minutes to get 1. You know what I mean? So even though we made the problem hella simple, 100 divided by 100 is 1. Then my style, and this has been working really good for me in the last couple months, is to go back and be like, what did I do to those numbers? And even in that, even when we made these two numbers totally the same, and then we stacked them 100 divided by 100, we really didn't know which one was on top, which one's on the bottom. But then you go for the answer. Oh, you want gallons per second, gallons on top, seconds on the bottom. So like I'm 95% confident that the answer to this one is just this divided by this, and then I realize that I'm going to be wrong because I haven't converted into seconds, you know what I mean? But who cares? You know what I mean? If this is 30 divided by 7, I don't even want to do that. What's 30 divided by 10? Okay, 30 divided by 10 is 3. You know what I mean? That's enough for my mind right now. And so that's going to be 3 gallons per minute. Okay, how does that compare to the problem that we just did? 100 minutes for 100 gallons, that would be 1 gallon per minute. Okay, so we're actually filling 30 gallons in 7 minutes. And so let's do it again. This is the juggling part. It's just like my mind don't even know what I just did. So I did 30, and we were dividing by 10. I don't like 7. So 30 divided by 10, that's going to be 3 gallons per minute. Okay, now the light bulb went on. It's like, whoa. It's like, whoa, this thing's filling up pretty good. 3 gallons per minute. Because we made the problem 100 minutes, 100 gallons, and it was a gallon a minute. But okay, so now we're doing 30 gallons. 3 gallons per minute. Okay, let's see what the problem asks. It says gallons per second. Yeah. And then even that, yeah, it's like, who cares? Just like, skip that one. Because that's the fork in the road, you know what I mean? Is it going to be smaller or is it going to be larger? You know what I mean? And cause even my mind can't really handle that right now. Like, obviously, gallons per second, like, just think about that. If I could fill up 1 gallon per second, holy Toledo, the hose burst. And it's just flooding out gas everywhere. That'd be a gallon per second. That would be like anyway, yeah, I think we got it. So obviously it's going to be, if we said it was 3 gallons per minute, it's going to be less than that. It can't be 3 gallons per second. And then you get into the same deal with like seconds and minutes being like 60 seconds. I don't like that either. You know what I mean? So what I do, this is a cool trick that you can do too. Because this whole thing is just to try to get the order of magnitude of 10. You know what I mean? So, and you might be off, because if I round this to 10, and then I round this down to 10, and then I round seconds. If I say a minute is 100 seconds, because that's the next thing we're going to do. We're going to say a minute is 100 seconds. Cool. So if I can fill 3 gallons in 100 seconds. Now that's what I'm saying. I'm saying a minute's 100 seconds. You know what I mean? So if I can fill 3 gallons in 100 seconds, see, and this is where humans suck at dividing numbers. You know what I mean? They can divide 3 by, like, you know, I can divide 3 by 2. If I have 3 and I divide it into 2, that's 1.5. You know, I think we get it. But the second you start dividing it any more than that, you know what I mean, it gets real. So what we're going to do is, so if we have 3 gallons per 100 seconds, and sure, let's talk about this, is let's say we divided 3 gallons by 3. Cool. So let's divide 100 seconds by 3. And man, you just got to assume it's going to be 30. Now you see, like, hey, actually using 60 seconds would have been way easier. But let's continue on. So if we have 3 gallons per 100 seconds, and then that's going to be 1 gallon per 30 seconds. Okay, so we're getting closer to gallons per second, but now we're saying that we have, see, this is the juggling part. We have 1 gallon in 30 seconds. So let's do a half a gallon in 15 seconds. Cool. Let's do a quarter of a gallon in 7.5 seconds. Cool. And then this is where you just say, no, I don't like 7.5. I'm going to do a quarter of a gallon in 10 seconds. Cool. So now I'm going to do an eighth of a gallon in 5 seconds. Cool. And now I'm going to do, and I'm just going to call that 4 seconds. You know what I mean? So I'm going to do a 1/16 of a gallon in 2 seconds and 1/32. I'm just going to write that down. You know what I mean? Because I'll totally forget. 1/32 a gallon every second. So sweet. You know what I mean? And yeah. So we're done. But no one knows what a 32nd of a gallon is. But yeah, let's see. Yeah. All right, I think I'm done with that one. You know what I mean? The whole idea is to not go down a rabbit hole of juggling. You know what I mean? Where you make your brain hurt more. So anyway, so we get it. Yeah, it's not very many gallons per second. Who cares? You know what I mean? No one cares gallons per second if gallons is going to be 0.00 what, you know what I mean? Just a dumb fraction. It would be better ounces, you know what I mean? Pint glasses per second, you know what I mean? Hey, that would be kind of interesting. All right, so now it says calculate the rate at which the 10, yeah, because this was, we got to a point where it's just like, nah, thanks, and we just who cares it, you know what I mean? But we could probably get there a lot easier if we did, if we said we were going to do 30 gallons in 10 minutes, that's going to be 3 gallons in a minute. So now we know a minute's 60 seconds. So that's going to be 3 gallons in 60 seconds. So let's do that same thing. That's going to be 1 gallon in 20 seconds. See, I just divided 60 by 3. So that's 1 gallon in 20 seconds. See, now we're doing the juggling. So that's going to be half a gallon in 10 seconds. Is that right? Yep. Half a gallon in 10 seconds. And then we got a quarter of a gallon in 5 seconds. We're just going to call it 4. So a quarter of a gallon in 4 seconds. And then we have an eighth of a gallon in 2 seconds and a 1/16 of a gallon in 1 second. So hell yeah. So now our answer is just getting better. A 1/16 of a gallon in 1 second. And the whole other reason to do the who cares method is like, hey, this answer jives. If someone said 32 gallons per second because they just messed up, you know what I mean? Well, maybe that's okay. You know, sometimes it's okay to get an answer that's horrendously wrong because it's all about the process. But this method is like, no. It's actually about getting the correct answer, you know what I mean? And then going back and doing your magic trickery with the actual equations, dividing and multiplying. But yeah, see how see how we got two guesses, and I just say these are basically about the same. It's who cares? They're about the same, and cool. So now could we even do this for real? You know, if we have 30 gallons divided by 7 minutes, you know what I mean? I can't divide 30 by 7, but I can divide 28 by 7, and that's going to be 20. Well, 7 times 4, right? 7 times 4 is 28. So it's going to be 4 gallons. So yeah, this is actually going to be 4 gallons a minute. Holy Toledo. So our answer is going to be not 1/6. We should get a little bit bigger. You know what I mean? So that's what we're hoping for. So we got 4 gallons in a minute. Yeah, that's going to be a half a gallon. No. If we have 4 gallons in 1 minute, that's 4 gallons in 60 seconds. That's 2 gallons in 30 seconds. So 2 gallons in 30 seconds, that's 1 gallon in 15 seconds. Okay, and so we're going to have to do that same thing. So we got 1 gallon in 15 seconds. Now we're going to do half a gallon in like 7.5 seconds. About 8 seconds. There you go. So are we at half a gallon? See, I messed it up already. Half a gallon at 8 seconds. And then we got a quarter of a gallon at 4 seconds. 6. Oh, whoa. Did I mess up even? Yeah, I don't even know how to multiply by 2. So we have a quarter of a gallon at... let's redo this one. Because this is fun. I mean, this is how... It's late at night, and I'm about ready to go to bed. But anyway, so we have... Yeah, so we're getting the right answer. So we have 4 gallons at 60 seconds. Basically 4 gallons a minute. Okay, so that means 2 gallons at 30 seconds. 1 gallon at 15 seconds. Half a gallon at 7.5. But I'm going to say half a gallon at 8 seconds. Cool. So we have a quarter of a gallon at 4 seconds. And then 1/8 of a gallon at 2 seconds. And 1/16 of a gallon at 1 second. So that just reiterates. And because sometimes... doing this, you do the who cares, and sometimes you get even closer, you know what I mean, using a who cares. So we're really centered on 1/16 of a gallon per second. I'm going to call that good. And even this, what is this? You know what I mean? How do you use the who cares on? I don't know what 1 divided by 16th is, but I know this is close to 10. You know what I mean? That's the whole thing of doing this. I'm not supposed to use pen, but 1 divided by 10, that's 0.1. Cool. You know what I mean? So this is 0.1 gallons per second. Cool. And no one knows what. Oh, check this out. Okay. Yeah, I don't know what 1/10 of a gallon is, but don't I know what 1/16 of a gallon? I don't know. You know what I mean? Isn't there? I do know there's 4 Nalgenes in a gallon. You know what I mean? Because a Nalgene is 2 pounds and a gallon is 8 pounds. So there you go. So there's 4 Nalgenes. And then if I divide a Nalgene by 4, that would be 16 of those. So a Nalgene is 32 ounces. And if I divide, that would be 16. That would be a pint. And then half of that, 8-ounce glasses. So heck yeah. So we're doing 8 ounces per second. Hell yeah. So booyah. And yep. And then so that's the answer there. 1/16 of a gallon per second, or about 8 ounces per second. And I think I'm pretty satisfied with that answer. You know what I mean? And because even if we just did it the other way, let's say we did 100 gallons in 100 minutes, that's going to be a gallon per minute. You know, you really can't mess that up. And let's say it was just 100. So that was 1 gallon per minute. Now we're going to say a minute is 100 seconds. So now this one's going to be real easy, because now we have 1 gallon per 100 seconds, and and the units are the equation. We have 1 divided by 100. Hey, that's 0.01. So we have 1 gallon per 100 seconds. So that's going to be 0.01 gallons per second. Cool. It's going to be 100th. I mean, it's spelled out. It's 100th of a gallon per second. Cool. So, things like that. This is way more valuable than trying to actually do the, throw it, because you might divide when you should have multiplied. You know what I mean? You get them mixed up. Anyway, all right, let's do the next one. Calculate the rate at which the tank is filled in cubic meters per second. You know what I mean? I don't want to do anything in seconds, that's for sure. That's what we kind of learned from this problem. It's nonsensical. It really is nonsensical. Like, to ask this is super dumb. But no. It's because you have to do this. Like, physics is hella small numbers and hella big numbers, and some like material mechanics, you have to combine like the biggest numbers. I mean, not the biggest, but like, you know what I mean, a billion. You know what I mean, 10 to the nines. You know what I mean, like 325 times 10 to the 9. And then at the same time, you got to do something with the number that's like, you know what I mean, 325 times 10 to the negative 6. You're just like, whoa, but both are like 300, but one's 10 to the 9, the other's 10 to the negative 6. Like, that range sucks. Like, you're just not going to, it's going to be, yeah, it's not going to be good on your mind. Anyway, all right, so this says calculate the, cubic meters. All right, and this is cool because no one knows what a cubic meter is. But, you know what I mean, this is where you do want to kind of write down your axioms. Like, where in life have I learned something? Because sometimes that is the place, like sometimes like a hella accurate thing where you just know it because it's an axiom. But yeah, this is a fascinating one. I know gas is like less dense than water, but a cubic meter of water is the definition. Well, two things. It's the definition of a metric ton. Like, and a metric ton is 2,200 pounds. Like, the normal ton in America is 2,000 pounds. But the metric ton is 2,200. You know what I mean? So that's just a good thing to remember. And so there you go. So even just from that, let me just use that. So if I know that 2,200 pounds of liquid water are in a cubic meter, well, how many pounds are in a gallon? 8, but I don't like 8. You know what I mean? So let's call it 10. You know, that's kind of the whole thing we're dealing with. So if I know that 1 gallon is 10 pounds, and we're going to take that 2,200 and just make it 2,000. We can't make it 1,000. We could make it 1,000, but things might get a little bit weird. So even this is a little bit juggly in my mind. Like, what the hell are we talking about? So we're going to say 1 gallon of gas is 10 pounds. Okay, so let's say 1 gallon of gas was just 1 pound. Well, and then we're saying a metric ton is 2,000 pounds. Well, wouldn't we have 2,000 gallons? If a gallon of gas is 1 pound, you know what I mean? I know it's not, but just mentally that's what I can handle right now. You'd have 2,000 gallons. So, by that logic, if a gallon of gas is 10 pounds, then I would have 200 gallons to make up a metric ton. You know what I mean? So there you go. And we're just going to run with this. So how the hell does this apply to our problem? Well, if it's going to take 200 gallons, and let's go back to our problem of just saying, hey, we're filling. It's going to take 10 minutes to fill 10 gallons. You know what I mean? So that's going to be a gallon a minute. Cool. And if I fill up 200, and it's going to take 200 gallons to do this cubic meter. All right, hell yeah. And so, and I can fill it in a gallon. See, even this, why is this so juggly to me? You know what I mean? So because I even totally simplified the problem. I'm saying 1 gallon per minute, and I have 200 gallons. Okay, so now the light bulb just clicked on in my head that obviously that's going to be 200 minutes. So cool. So we have our first Rust estimate. It is going to take 200 minutes per to cubic meter. You know what I mean? So hell yeah. So to do this cubic meter, it's going to take 200 minutes. Okay, so how many, at what rate will the tank fill in cubic meters per second? Well, a hell of a lot more. And if we're saying seconds is just, if there's 100 seconds in a minute, you know what I mean, which is not a very good estimate, but at least 60 rounds to 100. And it forces you to do that, you know what I mean? I don't think a lot of people actually want to round 60 to 100, but hell yeah, I do, you know what I mean? If it makes my brain not hurt, we're going to do it. So, if it takes 100 minutes and there's 100 seconds in a minute, you know, sometimes this is hard where you're just like, okay, 200 times 100, you could easily mess that up because that's going to be 2 with 4 zeros. So cool. I'm just going to write that down. 2, 1, 2, 3, 4, and then this. So it's going to take 20,000 minutes, seconds. So what rate? So it's going to take 20,000 seconds. But if I said 20,000, that would be a horrible answer because it says calculate the rate in cubic meters per second. You know what I mean? So if we could fill up a whole cubic meter in 1 second, we got an issue. You know what I mean? Like one of those big old tanks outside of town, you know, just ruptured and it's just spilling out like a fish tank broke or something. You know what I mean? So that would be a cubic meter per second. But this says, hey, if we're just filling it up at this, you know what I mean? So we did it. So it's going to take 2,000 seconds, but we're going to have 1 cubic meter per 2,000 seconds. So even this one, hell yeah, we're going to change it. I don't like 20,000 seconds, but I do like to round that down to 10,000 seconds. And we're not hella off, you know what I mean? So this is going to be 1 divided by 10,000, and even this is like 1, 2, 3, 4. You know what I mean? Go back to you know, doing that. And so we got so what we're going to have is we're going to have a 1. And then we're going to take this and we're going to go 1, 2, 3, 4. Booyah. Okay, so hell yeah. So you're going to have 0.0001. This is 1/10th, 1/100th, 1,000th, 1/10,000th of a cubic meter per second. Alright, hell yeah. I actually didn't realize like how simple and ridiculous this problem actually is, because this problem does require you to use factor label method, you know, if you actually just want to do it, and sometimes that's not that takes a lifetime of doing factor label method to actually get good at it, you know what I mean? Like I didn't get good at it in high school. I even went to college and really didn't, you know what I mean? But yep. Yeah, so yeah, I'll definitely do more videos on factor label because, you know, just even like the little, you know, ins and outs, you know, to not run into hiccups. Okay, but we're still using the guessing method. Okay, so we did that one. It is going to be 0.001. And then here's the crazy thing. Whatever we did to get this answer by like horribly guessing, but actually accurately horribly guessing, whatever we did to those numbers is exactly what you want to do to these numbers to get that answer. So does that make sense? You know what I mean? If I said a gallon is 2,000 pounds, you know, there's a few ways to do it, but that's the way I chose to do it. I was just like, well, how many gallons will fit in a cubic meter? Cool. And then, you know what I mean? If it's going to take 60, hey, it's going to be 17 minutes. But it's not going to be 60. It's going to be, what did we say? Yeah, we said it's about 200 gallons because each gallon is about 10 pounds. But even there, then it's also good to be like, well, we just guessed that a gallon was 10 pounds. Which isn't right. A gallon's only 8 pounds, and even for gasoline, it might only be 7 pounds. But anyway, and then we filled up, and we guesstimated that it was only 2,000 for a cubic meter. Not, it's 2,200 pounds, basically for a cubic meter. So let's put 2,000 pounds for a cubic meter, and So right there you would have, let's do 2,200. So we would have 220 gallons. Okay, so we would have 220 gallons to get that weight to 2,200. But we know we overestimated. We said a gallon of gas is 10, but it's not. So if we put 220 gallons in a cubic meter, we wouldn't get that same weight. We would get less. So we would actually have to put more in. You know what I mean? And maybe it's 230. Maybe it's 235. I have no idea. But at least that's also part of the guessing method. Is it's good to know what side of your, like, did you guess high or low? And do you know for sure? Did you know for sure you guessed high or know for sure you guessed low? But sometimes using this, rounding to 10, it's like I won't even worry about it. Because sometimes you'll round this up, and then at other times you'll round something down, and it might just, come out in the wash. Alright, hell yeah. We don't want to make this video too long, so let's do this last one. Determine the time interval in hours required to fill 1 cubic meter volume at the same rate. Determine the time I don't even know what this says. Determine the time interval. Oh, in hours required to fill. Yeah, so it's going to take 20,000 seconds. So we can do this one really easy because, you know what I mean? Because we know that 100 seconds is a minute. So you're just going to divide by 100. Hell yeah. So it's going to take 200 minutes. And we can do this. We can say again that, hey, there's 100 minutes in an hour. Okay, so we're going to take 200, and then we're going to divide it by 2 more zeros. So I think it's going to take 2 hours. You know what I mean? It's a horrible guess, but we're not off by we didn't say 0.4. So 0.4 is in the realm of 0.1. 0.1 to 0.4 is your 10 to the negative 1. Got it? I don't even think, actually, that probably blew your mind right there. But anyway, so, and then 1 to 4, hey, that's in the realm of 10 to the 0. And even 10 to the 0, no one knows what that is, but it's 1. You know what I mean? And then let's say you have 6 to 14. No, you got to go higher than that. It would be 6 to. I mean, to keep in pace, 10 to 40. You know what I mean? 10 to 40. Hey, now you're in the realm of 10 to the 1. You know what I mean? Hey, it's approximately 10. Cool. And then we're gonna have 100 to 400. Yeah, I think you get it. But yeah, so when we say 2 hours, we didn't guess 20 hours, and we didn't guess 0.2 hours. I think that is the easier way to say it. We didn't guess 20, we didn't guess 0.2. Now, you know what I mean? And, yeah. And so, hell yeah, we did it without a calculator at least. We did use a little bit of a pen, just to kind of, at key points. Now, and in my mind, I can't juggle too much in my mind right now. But let's try to get this one more accurate, and especially this one. So calculate the rate at which the tank is, and let's use this, because what did we get from our first answer? It was going to be like 0.16. This was gallons per second. Okay, so let's say it's just 0.1. Well, let's use another estimate. So we have 0.1 gallons per second. And we're going to assume that we need to fill that cubic meter up to 220. So it's going to take, and we can do a tenth of a gallon. So it's going to take 10 seconds for every 1 gallon. That's what this says, 10 seconds per gallon. And we need to have 220 gallons. So that's going to be 2,200 seconds. Cool. So now we have 2,200 seconds, and I don't know. I mean, 2,200. I mean, one other way you can do it both ways. So let's just write this down. Let's say you have 2,200 seconds, and then I say a minute is 100. There's 100 seconds in a minute. Cool. So that's going to be 22 minutes. But now I'm going to say, no, there's not 100 seconds. There's 100 seconds in 2 minutes. Cool. So I'm going to do divided by 100, and now I have 22 times 2. I have 44 minutes. So I know my answer is going to be between 22 and 44. And there was a couple ways to do that, but yeah, because if you said if you said there's 50 seconds in a minute, even that's a harder one to, do I divide, do I multiply, you know what I mean? I don't want to do that juggling. But just saying, hey, there's 100 seconds is 2 minutes. Okay, so how many 2 minutes do we have? We have 22 2 minutes. You know what I mean? So that's going to be 44. So we know the answer is going to be between 22 and 44 minutes. Now I feel like we're just fundamentally actually off. Yeah. What did we say? We said it takes. Yeah, let's check this. We got to double check our answers. So we have 1/10 of a gallon per second. Isn't that what we calculated? 1/10 of a gallon, basically 1/16 of a gallon every second. That 8 ounces. Okay, hell yeah. So that's going to be it's going to take 16 seconds to get 1 gallon, or we're just going to say 10 seconds. So we have 10 seconds to get 1 gallon, and then we need 2,200 gallons. No. We only need, and we're going to say 1 gallon of gas is 10 pounds, so we need 220 gallons to make up that cubic meter. And so it's going to take 10 seconds for each of these gallons, so it's going to take 2,200 seconds. Cool. Yeah, I guess that's just 44 minutes. Okay, so actually, our guess of 2 hours was pretty slow. And you know, this might only take 22 minutes or 44 minutes. So yeah, maybe we were off by more. You know, maybe it is kind of a 10 to the negative 1. So after yep. So that's kind of interesting. But how did we get this? Didn't we say this was 1 gallon per minute? But we can actually do 3 gallons. We can do 4 gallons per minute. You know what I mean? So if we said it took 2 hours at 1 gallon per minute, you know what I mean? Let's see that's where doing an easier problem, but then realizing how much you overshot at the end. And it's just funny that I'm not even, you know, it's kind of hard. It's like these are some of the things you pick up after the fact. But then you try to, have kind of a check on reality that, hey, like it was 4 gallons per minute. We have a speed of 4 gallons per minute, and I just guessed 1 gallon per minute to get this answer. So let's divide this by 4. So 2 divided by 2 is 1 divided. So it would be 0.5. So hell yeah. So 0.5 hours is very close to what this is. And then so yeah, right here we have a difference of it's either going to take 22 minutes or 44 minutes. So even this might be and obviously 30 minutes. 30 minutes is 0.5 hours. So hell yeah. So we're right in there. So now I'm glad we did that because we increased our get. I mean yeah. So I would say C, determine the time interval, 0.5. But you know what I mean. Were we off by a magnitude? You know what I mean. Were we less than 0.2? No. Were we more than 20? No. So I call this like within a magnitude of you know what I mean, kind of like 10. Or a magnitude of 100, let's say. So, you know, you're trying to get down to a magnitude of 10, you know what I mean, within that accuracy. But if you're within 100, I still think that's a check mark on reality. That's a very beneficial thing to know about a problem. Because if you mess it up, you could be astronomically, you could call that 10,000. And you'd be like, nope, I did something wrong. Alright, so, and then calculate the rate at which the tank is filled in cubic meters per second. Alright, hell yeah. So we're almost ready to check the answers in the back of the book. I just want to just go through mine and just say we increase this to 0.5. That's going to be a hell of a good check on reality. Calculate the rate at which the tank is filled in cubic meters per second. So now I'm going, we said it was going to be 1/10,000th. So even here, I thought it was going to be 1 divided by, 1 divided by 20,000. I just didn't know what that is, so I did 1 divided by 10,000. See, but right here now, here's where you get tricked up. You know what I mean? 1 divided by 20,000 isn't just 0.002. You know what I mean? So this is where you use that, like, hey, isn't 1 divided by a bigger number? Isn't this going to be a smaller number? So I kind of do that. 1 divided by 10,000 is going to be the bigger number. This is going to be a smaller number, and so it's not multiplied by 2, it's divide by 2. You know what I mean? So this is going to be 0.000 and then 0.5, because you could say, hey, this is 10, and then divide by 2, that's going to be 0.5. You know what I mean? So that's what we get. We get 1, 10. Oh, this is really hard. The 3 is, this would be 1,000th, this would be 10,000th, so we have 500 thousandths of a second. It would be 500, am I saying that right? 10th, 100th, 1000th, 10,000ths. This would be 100 thousandths, but we have 500 thousandths of a cubic meter per second. Now, I'm not confident about this one at all, but we can use this idea that we did it in 0.5 hours. Determine the time interval in 0.5 hours required. And so now we can go back and figure out what this is in seconds. I can just say, hey, there's going to be 100 minutes in an hour, so we're going to go, that's going to be 50. So we got 50 minutes for this. And then if we have 50 minutes and we know that there's 100 seconds in a minute, you know, we just go another 2 zeros. So we have 5,000. So I would say it's 1 divided by 5,000. And why is this 1 divided by 20,000 and we're getting 1 divided by 5,000? Well, it's because we chose, for our simplified problem, 10 gallons per 10 minutes, 1 gallon per minute, but we're filling it up 4 times faster. So even just right here, it isn't 1 divided by 20,000 the smaller number, but 1 divided by 5,000, like, isn't this just, if we multiplied this by 4, hell yeah, well, you know, wouldn't this just be 2 divided by 10,000, and then that would be 1 divided by 5,000. So that's exactly what we're getting, and so now here will be a better check on reality. And I don't know how to write this as a fraction, but I do know how to write 10,000. So this is 5,000, this is 10,000. It's going to be 1, 2, 3, 4 zeros, 0. So I do 4 zeros and a 1, and this is, did I do that right? I don't think so. Yeah. 100, 1,000, 10, no. So it's no, I did it. This is 1 10,000ths. 4 zeros. No. It's moving 4 zeros, but we got to take this 1 decimal place right here and go 1, 2, 3, 4. Yeah, that trips me up all the time. You know what I mean? I always have to say, like, if this is, this is also, oh, this is really good. So this is also 10 to the 4. You know, this is where exponentials will really help, because this is 10 to the negative 4. Cool. And and this is 1 times 10 to the negative 4. And so anytime you see this negative 4, for whatever reason, I just know it, you know, there's only 3 zeros in front, then the 1. But it trips me up all the time. But anyway, so if I have these 4 zeros down here, I take the number 1 and then go back 4 zeros. And this is going to be 0.0001, and we're not even, and so this is 1 10,000ths. Okay, but we have 1 5,000ths. So which one's the bigger number? This one has a bigger number down below, so that's the smaller number. This one is the bigger number by a factor of 2. So okay, this is going to be twice as big, so hell yeah. So we're going to get 0.0002, and that should be our answer. So we're going to get 0.0002 cubic meters per second. Cool. So in the back of the book, we're trying to shoot for this answer for B. That was our just guess, and we're trying to shoot for a 1/16, which is close to 0.1. And will this be a little bit smaller? Hell yeah. So if our answer is going to be smaller than 0.1, wouldn't we expect like 0.08, 0.06, you know what I mean, something like that? I don't even know what that would be. But hey, you can do this. What's 1/20th? So if I have 1/16, and I'm assuming it's like 1/10, but I know it's smaller, well, let's just go up to be like, hey, what's 1/20th? And then, you know, if 1/10 is 0.1, and 1/20th is the smaller number, because it has a bigger, and it's a smaller number by a factor of 2, you know what I mean? So this is a really good trick to do. Instead of just writing this as 0.1, it's hard to see what you do. Write it as 0.10, you know, 0.10, and then if I half this, it would be 0.05. So heck yeah. So 1/20th is 0.05, 1/10 is 0.1, and we had 1/16. Now, and this is where I get even confused. Is like, well, it's not exponentials, is it? You know what I mean? It isn't. There's no exponentials going on, so it should be fairly linear. Like, it isn't 1 divided by 15. Shouldn't that be halfway between? I'm just going to do that because my mind can't handle it. Is 1 divided by 15 just halfway between these? Is that going to be 0.75? You know what I mean? 1 divided by 15. No, it's not. So it is a little exponentially. You know, isn't that right? Because we got 1 divided, unless I'm just making huge errors. 1 divided by 20 is 0.05. 1 divided by 10. It is. So yeah, it's a little exponentially. You know what I mean? Because you have 1 divided by x, and if you graph that, heck yeah, it drops off real steep and then kind of mellows out. So we're not going to figure that one out before we finish this video. All right, so yeah, that was crazy. That you know, I was just like, well, isn't it linear? But hell no, you know what I mean. So, but that was kind of fascinating. Yeah, and no duh, because if I have I don't even want to get into it. So anyway, so I think we're good to go. So we're gonna try to get something that's let's see, what is 1 divided by 16? 0.0625. So we're trying to shoot for something right in there for this answer. And for this one, we're trying to shoot 0.0002. That's 2 10,000ths. Because the third place would be 1,000ths. I kind of know that from machining stuff. You know what I mean? You always deal in thousands. But hell yeah, this would be 20,000ths. I mean, no, this would be, 20. This would be 2,000ths. This would be 20,000ths of whatever. All right, so this is 20,000ths of a cubic meter per second. That's our guesstimate for B. A is going to be 0.06. And then the time interval is 0.5 hours. All right, without further ado, let's look this one up and be done. Man, this seemed like a simple problem. You know, I didn't try to make it complicated, but yeah, it's just kind of fascinating. All right, so we got 0.07. Perfect, you know what I mean? So we were thinking 0.06, and even we were thinking 0.1, you know what I mean? So hell yeah. So we're within an order of magnitude on that one. Okay, now this one, well, they're showing it as a funky number. Yeah, no one likes. They're saying 2 times 10 to the negative 4. What did we say the trick is? 3 zeros out front. So if we go 0.000, that third zero is the thousandth, so this is a 0.0002, so that's going to be in the 2,000ths, you know what I mean? And that's what we got. That's our answer was 2,000ths. There's 2.7. So it's just amazing how this system works. And I'm just bummed that they only give it one page, but they actually include it. I'm sure there's plenty of physics books that do not include this estimating in order of magnitudes. And then you have, oh, it's 1 hour. Yeah, that's fascinating that we guessed 0.5 and we were pretty solid with that. But then, yeah, but anyway, we thought it was 2 with the 1 gallon per second, and then we thought it was 4 gallons per second. And so we decreased the time by 4. But yeah, we were more off on that one. And determine the time interval. Yeah, so let's kind of check our error on that. Because if we were pretty satisfied with this guess of 0.0002, now how do you turn this back into a fraction? Well, I go 0.0001 and I say that's 1 divided by 10,000. But now this number is bigger, you know what I mean? And don't get it confused with this 1 divided by 20,000. No. This 20 thousandths is bigger than 1 10,000ths or 10,000ths. So hell yeah. So this fraction, to make this a bigger number, this has got to get smaller by a factor of 2. And so we have that 1 divided by 5,000. I was just taking my time to get back to here. All right, so what this says is that we're going to fill 1 cubic meter in 5,000 seconds. So this was our estimate. And, you know, I guess the biggest take home, you know, we were trying to guess of like, hey, there's 100 minutes in 100 seconds in a minute, 100 minutes in an hour. Well, there's not. There's 60 minutes, 60 seconds in a minute, 60 seconds in an hour. And obviously you know that. But how many seconds are in an hour is 60 times 60. And this number, you just, from an engineering perspective, you just have to memorize it. You know, don't memorize pi. You know what I mean? That's jabbing at the math people. But anyway, memorize 3,600 seconds are in an hour. So then, hey, this is going to take, to fill up 1 cubic meter, is going to take 5,000 seconds. Okay, you know what I mean? That's going to be more than an hour. If this was 1, and then this was 3,600 below, and then what was the answer? Because the answer was 0.00027, you know what I mean? So this number comes down a little bit. So it is closer to 1 divided by 4,000, 1 divided by 3,600. And then the actual answer is 1 hour. But if we use this as our guess, you know, and double checked, we would have basically an hour. Or from this guess, we would have more than an hour. Basically an hour, not an hour and a half, but more than an hour and a quarter from this estimate. So yeah, it kind of makes me want to go back and be like, well, how did we calculate the rate, you know, at which this was going to be filled? Yeah, how did we get that first estimate? Well, no, it was interesting because we got this, but I get it. We got this from just doing a really haggard guess, and I can see where my error is. It wasn't on the 10 gallons per 10 minutes. That was going to be a gallon per minute, and if we did that, we would have got 20,000 seconds. Cool, but if we have 20,000 seconds to fill up a cubic meter, we go 20,000 divided by 3,600. Oh yeah. We go 20,000 divided by 3,600, and our answer should have been 5.5 hours. But we did 20,000. Oh, we not only, I think, didn't even do 20,000, but 20,000 divided by 100 divided by 100. I think that's what we did. You know, we did 20,000 divided by 10,000. where it should be 20,000 divided by 3,600, and this should have been 5.5 hours. And then from there, we would have realized that our rate is 4 times more, so we divide by 4, and you get closer to the answer in the back of the book of 1.3. But anyway, so, but the whole goal isn't to dial it in, you know what I mean, hella. It's to get within an order of magnitude of 10. So even saying 2 hours, hell yeah, that is an incredible guess. Because that guess is way better than being 20 or 0.2. So that's kind of the take-home point. And you might hate guessing like that. But I'm going to try to do it more just because it does foul you up. Because like sometimes you will be off by a factor of 4, like we have been for that answer. And then trying to nail it down, and then you're off by a factor of 2, and then you're kind of bummed out. Alright, hell yeah. So my camera died, but yeah, the point is to be, cool. It'd be way cool if you're in a factor of 10. But even this, I try to get into even sometimes this range. Am I within a factor of 100? And can I honestly say that I could bet my life on it? You know what I mean? Could I bet my life on being in an order of magnitude a factor of 100? You know what I mean? And sometimes that is a good skill. You want to have a who cares perspective, but then also outside of that is just like, well, like shouldn't my answer be like 100%, you know what I mean, with some outlier, but within a certain range, you know what I mean? It's just like, that's kind of where you want to be. So alright, so that kind of ends the video, and yeah, let's do some more of these. Alright, thanks for joining me, and that's a video.